Hey, how's it going? Today we're going to look at surface area, and in this whole chapter, chapter 11 is on three-dimensional objects. So we're going to do surface area, not just flat area, but surface area, and then we'll also look at volume in this chapter. Today we're going to look at all things surface area with prisms and cylinders and pyramids and cones. It boils down to just knowing some formulas and being familiar with those. So let's look at an example here. These are prisms. A prism is going to have two bases, one on the bottom, one on the top. Those are going to be the same shape, and then all of the faces, all these sides here, are going to be rectangles. That's how you know you've got a prism. In this case, we'd have a pentagonal prism. It's named based on its bases. And then these are called lateral sides or lateral faces. Lateral means the side. Okay, this next one's a triangular prism because the bases are triangles. A right prism just stands straight up with a right angle perpendicular to the ground. It can lay on its side and still be considered a right prism. An oblique prism is something that tilts off to the side. And we'll deal with some oblique prisms, but mostly be dealing with right prisms. All right, so first I thought maybe we should practice drawing some of these so that when you're drawing pictures and filling in stuff, you can draw it. Because when you draw a square prism, you typically kind of look at it from an angle, and so you don't really draw a square for the base. It typically will look like a parallelogram. So try to draw, and really it might be more of a rhombus than anything since this is supposed to be a square prism. But you do one like that, and then you do another matching one right above it. And try to make it match and line up the same way. Because what you're going to do then is join all the corners. If it's something that's in the back and you can't really see it, we typically will dash that. Okay, there's my square prism. Okay, a hexagonal prism. Now, in the last chapter, I really emphasized that you should draw your hexagon so it really looks like a regular hexagon. But when you're drawn three-dimensionally, you kind of want to skew that again. You want to kind of tilt it and slant it, maybe make it a little skinnier. So here's typically what my regular hexagonal prism looks like. I kind of make it long and skinny, and then I do another one up above here that matches it. And then start merging corners. If it's in the back, we dash it. If we can see it, we solid line it. And there's my hexagonal prism. Okay, now we're going to use, before we get started, we're going to look for surface area today, and I want to look at a net of that surface area. Remember when we made the net of our polyhedra, it's just all laid out flat. And if I'm going to look for the surface area of this prism, so this is my prism right here, here's the net that would make that prism. The base is a 3x4 rectangle. You can see a 3x4 rectangle here. And then it's 5 centimeters tall. And if I want to find the surface area, ultimately I'm just finding the area of all of these faces. And then I'll just add it all up. Now if you look at it, let's look at what we would have. Let's start with this. I know that this is broken off into 4 rectangles, but can't we just take those 4 rectangles and merge them into one big rectangle? And then this, the height of it would be 5, and the base would be all of these added up. So 4 plus 3 plus 4 plus 3. And that would be 14. So I could do this rectangle here, a 5 by 14 rectangle. And then I could find these 2 rectangles. If you look at where those are coming from, those are your 2 bases. And so I would find the area of that base, that's base times height, so that's 12, and that's 12, and I would add those into my big rectangle. Now what I'm ultimately looking for here is a formula. So let's start with this big rectangle. The 5 is really just the height of your prism. And this long leg here is really just all these sides added up. If you look at it, it's this plus this plus this plus this. And if you think about it, well, that's just the perimeter of your base. to get this rectangle, I need to take the perimeter of my base times the height. And that right there is the surface area formula for, well, it's the start of a surface area formula for a prism. So it's surface area equals the perimeter of the base. Anytime you're dealing with the base, you use a capital letter. And then it's times the height of your prism. Now what I haven't taken into account yet, though, are the two bases. This base and this base need to be added in. Now, because that base is not always a rectangle, sometimes it's a hexagon, sometimes it's a triangle, I'm going to keep this formula very generic, and I'm just going to say, take the perimeter times the height. That's going to get us all these lateral faces around here. And add in 2, and then I'm going to put capital B, and capital B means area of the base. So if it's a hexagon, I'll find the area of the hexagon, and then take it times 2, and add that in. If it's a triangle, then find the area of the triangle, take it times 2, and add it in. But this right here is kind of our go-to formula for surface area of a prism. All right, so here we go. Let's just do a few of these. What's the surface area of the triangular prism? It says use a net. Well, I'm not going to use a net because I have a formula I just figured out. And my hint on this is to remember there's always 2 matching sides that are the bases, because this right here is what we would call a triangular prism, but it's like sitting on one of its lateral faces. The base is really the matching triangles. So you have to think of, when I do area of the base, I'm talking about these 2 triangles. So if you would prop this thing up and make it sit on its base, how tall do you think it would be? It would be the 12 centimeters tall. Okay, so in your notes here, you can see I've goofed up. It says surface area equals pH plus, and there should be a 2 right here. So fix that in your notes. pH plus 2b. So let's fill in what we can. The capital P is the perimeter of the base. The base is the triangle, and the perimeter would be those 3 sides added up. So 5 and 5, that's 10, plus 6. The perimeter is 16. Now the height, if it were sitting on its bases, the height would be 12. Plus 2, and now I have to do the area of the base. And the area of the base, I'm going to come over here and do area of the base. It's a triangle. I have to go back to last chapter. Area of a triangle is 1/2 base times height. And now I'm just looking at the triangle itself. When I say, see how that's a lowercase b? That just means the b that's the base of the triangle. And then I'm going to need the height of the triangle. And what I know is that these 2 sides are 5, and the whole bottom is 6, which means when I drop that height, this becomes 3. Okay, so 1/2. The base, well, I talked about it, that's 6. The height, I'm going to have to work on. This is not a special right triangle, but I do know that this would be 3, and this is 5, and I could do a little Pythagorean theorem to find that height. So that's what I'm going to do. I'm going to do a squared plus 3 squared equals 5 squared. So a squared plus 9 equals 25. Subtract the 9, I get 16, so A is going to be 4. Okay, A is, and that's the height, right? That's going to be that measurement there, so I'm going to put a 4 here for the height. So 1/2 of 6 is 3, times 4 is 12. And that 12 gets put in right there for capital B. All right, now you're ready to go to your calculator and do 16 times 12, and that's 192. Plus 2 times 12, that's 24. Add those together, and you get 216 centimeters. It's still surface areas, so we square the units on that. Okay, definitely using stuff from the last chapter here. Now, one of the things I should clarify before we get too deep into this, if they're asking you for the lateral area, that's going to be just the sides of it, and you don't have to add in the bases. So if they want the lateral area, you would just do the perimeter times the height and then be done. If they want the surface area, then they're going to want the whole shebang. They're going to want the perimeter times the height, but you have to add in the two bases. Pay attention to if they're asking for just lateral or if they want the full surface area. All right, looking at this problem, it looks like I've got a triangular prism. This one is sitting on its bases. You can see here we have a triangle and then a triangle down here. So those matching triangles are your bases. So that's what I'm going to have to end up finding the area of. And then this over here is going to be your height that you'll need. So to do these problems, let's try to keep this sort of organized. And I'm going to go ahead and I'm going to do my surface area formula. And I write it kind of big. Surface area is equal to the perimeter of the base times the height plus 2 times the area of the bases. Now what I'm going to do is kind of do this a little bit in parts. The perimeter of the base, that's the perimeter of this triangle. Now I'm going to have all kinds of side notes here, so try to keep your side notes organized also. But to find the perimeter of that triangle, and it might help if you kind of draw it out so it really looks, because you can see it's supposed to be a right angle. You're just looking at it from a funny angle, you don't see it as much, but that's a 3 and that's a 4. And we just got done doing one like this, where it was a 3, 4, 5 triangle. Remember, that's a Pythagorean triple. We come across that one a lot. It's maybe worth remembering. So I don't even have to do Pythagorean theorem, though I could if I didn't remember 3, 4, 5. I could do Pythagorean theorem and I would have gotten a 5. Ultimately, though, remember, I'm looking for the perimeter. So that'd be a 3 plus 4 plus 5. That's 12. So my surface area is equal to 12 times the height. That's 6. Plus 2. And now I have to do area of the base. Now, the base formula in this example is it's a triangle. So that would be a 1/2 base times height. Now I'm going to start going through and I have to find then the base and the height in this triangle so I can fill that in. So I'm going to go one more line here. If you want to start multiplying things together, you can. 12 times 6 is just a 72, so you could do that. But you kind of got to group this and then you got to group this because you're adding in between there. So over here then I'm going to have my 2 times my 1/2. Maybe you multiply that, but it's going to be the base times the height in this triangle here. So we're lucky because you have a right triangle and your base and your height here is the 4 because it's perpendicular to this base that is 3. So I can just fill in those numbers. And now I'll go ahead and clean that up. Again, kind of leave these separate until the end. 2 times 1/2 is 1 times 3 times 4. So that's 12. Add those together and you have 84. You're finding surface area, so that's centimeters squared. This one appears to be a hexagonal prism, and you can see here that here's a hexagon. The faces are rectangles, but there's a front and a back to this that are hexagons. This prism is not really sitting on its base, so you'd have to think of it as pushing it up and making it land on top of the hexagon, and then it would be on its base. If it was pushed up and sitting on its hexagon, it'd be 12 units high. So this 12 here is actually the height of the prism, and this hexagon, and you can see it's a regular hexagon, will be my base. And that'll be what I'm dealing with, is that nice hexagon. Okay, let's go ahead. Now this kind of walks you through. It says, what's the lateral area? What's the area of the base? Add them together. There's your surface area. I don't really need to do this as answer to A and B and C. They're just kind of hinting at the process. So I'm going to start off with my surface area formula. And I know that it's the perimeter times the height plus 2 times the area of the base. Now here's something we might start doing. What if I went ahead and wrote perimeter times height plus 2 and then acknowledged, okay, the base is a hexagon. How do you find the area of a hexagon? Well, that's a 1/2 AP. P. So I'm going to replace my capital B, area of the base, with the appropriate formula. And then I can start filling some things in. Let's see what we know here that we could fill in. The perimeter of the base. Remember, the base is the hexagon. And they tell us right here that a side is 6, and we have 6 sides, so your perimeter is 36. And remember that the height of your prism, if it was sitting on its base, would be 12 units high. Plus 2 times 1/2, those are going to cancel nice for me. And now here's where it starts to get tricky. I have to know what the apothem is. That's going to take a little bit of work. But the perimeter, I already know it was 36. So I'll leave a little space. I'm going to put my 36. Let's go work on that apothem. They did a really nice job of making this hexagon look like a nice regular hexagon. So I'm going to use it. I'm not going to redraw it. I'm just going to drop my apothem and my radius and create this nice triangle here. Now hopefully you remember from last chapter that that creates a nice 30, 60, 90, where the apothem is your long leg. Now, the whole side was 6, which means this little piece is 3, which means your apothem, your long leg, is 3 root 3. If that's my apothem, I'll put it right here, 3 root 3. Now the directions say to find the surface area rounded to the whole number, so I won't have to keep track of that radical. I'm going to go ahead and just multiply it out. But let's go ahead and let's do this again in parts. That plus sign is kind of important to keep your parts separate. I'm going to do 36 times 12, and I get 432, plus 2 times 1/2 is just 1. Those are going to cancel. And then I have this 3, and I'm going to just type this in my calculator, 3 times the square root of 3. But don't forget to close your parenthesis on that, because now I also have to take it times 36. And I end up with 187.06. So this didn't come out as nice because of the radical. Now I'm just going to keep that number in my calculator and type plus 432. So I'm not having to retype everything. And I get a grand total of 619.06, but it does say round to the whole number, so I'm just going to call it 619 meters squared. Now, a cylinder is really just a special type of prism. So if you look at this, it still has 2 bases. It just happens that in a cylinder, the bases are always a circle. Okay, and if you think of like a label on a soup can, if you were to cut that label off like this, it would lay out flat as a rectangle. So to find the surface area of a cylinder, you're going to find the area of this rectangle and add in the 2 bases, just like always. And the area of this rectangle is the height times this length right here. But remember that that length just wrapped around the base, and so it would fit perfectly around this circle. And that distance around the circle is the circumference, 2 pi r. So I think what we have is a special formula here that we can use then for circles. We're still going to say the surface area is equal to the perimeter times the height plus 2 bases. But what's special here is your perimeter is really your circumference. So I'm going to put 2 times pi times the radius. And then I'm going to take that times my height. Plus 2, and then a capital B means area of the base. The base happens to be a circle, so that's going to be the area formula for a circle, pi r squared. Now you do not need to remember that. What you do need to remember is the area of the base formula and the circumference formula, and you'll fill that in as you go. I'm going to fill in numbers. I think I've got it here. Surface area equals 2 times pi, and then let's read up here. A cylinder has a height of 9 centimeters, a radius of 10. What is the surface area of the cylinder in terms of pi? So this time we're not going to round. 2 pi, the radius is 10, the height is 9. plus 2 pi. The radius was 10, so I'm going to take 10 squared. All right, now I'm going to come up here. 2 times pi times 10 times 9. I'm just going to leave pi in my answer and do the 2 times 10, that's 20, times 9, that would be 180 pi. Plus, now I'm going to do the area of my base part, 2 pi 10 squared. 10 squared is 100, times the 2, that's 200 pi. And then this works just like it does with x's. You can just add these together. That's going to end up giving you 380 pi. And that's your answer right there. And that'd be centimeters squared. So if they ask you to leave it in terms of pi, don't ever type 3.14 in, or don't use your pi button. All right, that's all I've got for you. Good luck.